Hello, everyone. My name is Xuyang. It's an honor to be invited to give a presentation at GIS Day at York University. I guess some of you still know me, but let me briefly introduce myself first. I was a master's student at York University. I was supervised by Professor Armanakis and Professor Jadidi. I graduated this June and I joined Mapsted this July. So I have been working for Mapsted for around 4 months. So actually I'm still learning a lot of things. I will give you some general introduction about Mapsted and the indoor navigation technology based on my understanding. And hopefully you can get some research inspirations from my presentation. So, so what is Mapsted? Based on the description in our website, Mapsted is an innovative Canadian indoor positioning company and a world leader in indoor navigation solutions. We give your business the power of effortless navigation, hyperlocal intelligent marketing, and detailed insights into customer behavior with power of real-time analytics. Our standalone patent indoor positioning system doesn't rely on use of external hardware to determine position, make it highly accurate, scalable, and inexpensive. So basically in plain world, we are doing indoor positioning. Our technology is good because we just use our phone, do not require any external equipment. And our technology is implemented in all sorts of industries, and we have customers around the world. For a user, you can find a way in a mall, hospital, or museum. For our clients, they will have some analytics tools. For example, a mall can visualize where most customers are visiting. A country is holding elections and will use our technology to monitor close contacts under this COVID situation. We are expanding our market for higher education. We launched a new platform called Campus Go, and I hope we can work together with York University as well. Before I talk about other technologies, I think I have to mention GPS first. We are all very familiar with GPS. It's a very commonly used technology for positioning. Typically, GPS can reach 5 meters to 10 meters accuracy in an open outdoor environment. But GPS is not working well in indoor positioning. The main reason is that the power of the GPS signal is too low. After traveling a long distance from a satellite, the signal is further compromised by the blockage. Sometimes cannot even enter the room. So the signal strength arriving at the GPS receiver is too low to be usable. So it is possible to calculate the location due to the insufficient signal strength inside the room. So we need to look for other signal sources. The commonly used ones are Wi-Fi and Bluetooth. Nowadays, as long as you have a phone, you can use it as a signal receiver to get Wi-Fi and Bluetooth signals. And Wi-Fi routers, Bluetooth beacons are widely available in the malls, for example. Generally speaking, the strong RSS means you're closer to the access points. The weak RSS means you are further. Once you have multiple signal sources, you may estimate your position. So comparing between the Wi-Fi and the Bluetooth, Wi-Fi has a large signal range. So Bluetooth signal is more accurate. But in order to use the Bluetooth signal, the mall needs to install some Bluetooth beacons on the wall. And every several years, those beacons will need some maintenance, otherwise they can be out of battery. So it means extra cost for higher positioning accuracy. Before using the RS data, calibration process is required. Basically, we need to design some locations to collect fingerprint data and then collect RS data in all those points. And then a new target, when a new target is in this area, we can match the RSS received by this device to a finger point to get a better estimation of the position. There are also sensors on our phone that we can take advantage of, like accelerator, gyroscope, magnet, yeah, a barometer. So here are the examples how to interpret the sensor data. The accelerator, we can get the motion data and then use that to detect the steps and then predict how far we walked. The gyroscope, we can know the rotations and then we can detect the turns. For the barometer, we use that for design the fluid detection algorithm. For example, the signal means you are going upper level and the lower level. For the RS signals, if we see a decrease significantly for the signal, we assume you go to a room from the pathway. But these sensors have a huge shortcoming, which means like when they are like, they will accumulate the errors. For example, this step detector, if there's some deviation on every step, after 1 minute's walk, the prediction can have a huge difference from the ground truth. So after giving you a brief introduction on these indoor positioning technologies, you may feel that all these data sources can be helpful, but none of them are very perfect for this indoor positioning prediction scenario. So we cannot just rely on them alone. So here's how the Mapsted handling this problem. We do collect all this data. Also, we have some machine learning algorithms, and then we use a data fusion algorithm to combine this data together to provide the best estimation based on this data input. So the advantage is all these data sources can be optional. For example, some properties do not want to install Bluetooth beacons on the wall, so we don't have the Bluetooth RS data. Or some phones are too old to have parameter sensors, then we need to rely on like other sensors. So we are still able to give you a prediction of indoor position, but more data means better estimates. Before I give you a demo, I need to mention the self-correcting algorithm we have. So for example, a person is walking and then turn left. So the system gave you a wrong prediction here. It's supposed to go to this pathway, but the system thought it go to this room. But since it's still going north, which is impossible if you are in the room because there's a wall. So the system will do a self-correct to realize that this black line is actually the right trajectory. So in the demo, you can see some of this self-correcting here. The demo I'm going to show you is like what we call a data capture. A person uses our app, goes on site, and set the points, like the calibrator will follow. Once you think you're at this point, you click this button and move forward. So along this path, all the signals are collected, or like all the data are captured. Then we can replay this data capture remotely on our server. We can do testing and adjusting the parameters to find the best positioning estimation for this place. And then we do not need to physically go there for testing again. So let me play this demo for you first. You may be very confused about what are these. The blue dot is the predict location based on all the data sources. The black dot is the ground truth based on the calibrator's input. The darker zone here means the Wi-Fi signals, and those two lines are inertial sensors. The direction are randomly generated at the beginning. We just care about the relative direction, like there's a turn. So those are small dots, are these particle filters. Each of the dots can be considered as a potential location. At the beginning, 100 dots are initialized. It follows the blue dots like minions. They will die if the possibility is too low, and it will be reborn after being killed. So let me play this one for you again. So you may realize the blue dots actually following the ground truth pretty well. And then also you may notice some self-correcting here. Okay, let me give you some overview of our system. We have a pre-processing module, like the map contents and calibration data. And then a real-time module gets the signal from the phone and the process in real time to get the predict location. And then we have a post-processing module that save the data and the process for analytics, and for us to do some adjustments. Yeah. So even though the Mapsted technology already works very well, we still need to have optimizations on a lot of places. And we look forward to seeing more researchers working in this indoor positioning area. I would like to provide you some research directions if you're interested. Like if you, like me, decide to go for a PhD, here are something I want to research on in this field. So one chapter of the dissertation would be data management. Like indoor position requires a lot of geospatial data, like coordinate system, POIs, walls. They're very crucial for the routing. So it is very important to have a system to efficiently manage those geospatial data. Mapsted manage all the data into property level, building level, and floor level. Like a mall can be a property, York University can be a property as well. And York University have many buildings like Pertwee, Bergeron, and then Bergeron have many floors. Each floor has a lot of console entities, and they are consisted by polygons, polylines, and points. As I mentioned before, the pre-processing module also process the calibration data. So there are things like how to design the calibration regions, what data needs to be collected, how they're stored in the database. There are tons of details to figure out. It can be very helpful if we have some innovations on the PMS to make the whole process more efficient. Another research direction would be the algorithm to process RSS and sensor data for better positioning estimation. Like you may pick several of them and then have some improvements comparing to the existing state-of-art algorithms. If each of them can provide a more accurate positioning prediction, it will have an impact on the overall estimation. So the last one is data fusion algorithm. The commonly used fusion algorithm are common filter, particle filter, to combine all those data sources together. There can be some optimization here, like if all the data sources are the same, if the data fusion algorithm is better, we can also get a more accurate positioning prediction. Like I mentioned before, we are launching a new platform called Campus Go for higher education. The differences of indoor positioning in the mall and in a university is that a university always have many buildings. The students will navigate from buildings to buildings. So sometimes we need to give higher weights to GPS since it's very accurate outside. And then when indoors, we rely on other data sources. So it's a question how we can smoothly transit from indoor and outdoor. Mapsted has already worked with University of Windsor for a long time. And this building detector algorithm is actually quite mature now. I hope your university can also collaborate with Mapsted on this Campus Go platform. Beneficial for the students of wayfinding, also for the researchers if you're interested in this do indoor positioning, it can be very easier for you to get started. So that's all my presentation today. Hopefully I provide some inspirations for your research.